when you design a park, when you think about the architecture of the park, you might want to do a big alley and make it look grandiose and whatever. That's the design. So what you think what you want to do with the park. But at the end of the day, the users, they have a specific objective when they go through the park, and they might want to take a shortcut because there's an exit on the right. And because we're busy people, we might not necessarily follow the path that the designer or the architect had in mind for us. And that is user experience. User experience is how the end users are using the product, how they are interacting with it, what is their experience with it. Is it pleasurable? Is it, can they accomplish their goals easily or not? And the whole idea is to, when we design something, to not wait until the product is shipped, is to try to anticipate how users are going to use our product. And we do that by placing the human that's going to use the product at the center of what we do. So user experience is an approach. It's a way of considering the human factors, how humans interact with something when we're creating objects, systems, services, or games. And the thing is, the experience that we have with something, so if you think about a video game, the experience that you have with the video game happens in your mind. And so if we want to anticipate how people are going to experience something, we need to understand a little bit how the mind works. And this is what we're going to see soon. But user experience is really to try to understand how our target users are going to perceive and interact with a game, in our case, including how engaging the experience is relative to the design intention. This concept of UX was introduced by Donald Norman, who is a UX designer and a cognitive scientist. And he wrote the very well-known book, The Design of Everyday Things. It's like really a...
I have a meeting.
Yeah. Can you hear me okay? Or is there a problem with... Oh, did you want to record?
No, I think it was someone accidentally unmuted themselves.
Oh, okay. But did you want to record? Is it recording?
Yeah, it is recording.
Okay, cool. All right. So I don't know where. So Donald Norman, who is a UX designer and also a cognitive scientist, he wanted to find a term to really take into account the whole experience a user is going to have with an ecosystem. So not just when they're interacting with the product itself, but also how they hear about it the first time, the advertisement, or did they hear about it from a friend, or did they see something? Was there an advertisement campaign? And then if they go to the store, Donald Norman was VP at Apple at some point. So if you think about the experience of the Apple store, it's very specific. So it's all about what experience you're going to have at the store, what experience you're going to have if you download a product or if you unbox a product. Also, of course, the experience you have with interacting with the product itself, and then how you remember about your experience, how if you need to contact the customer service because something is not working or you're not understanding something well, or if you communicate with the community managers in the case of games. And so the user experience is all of that. It's considering all of that at every step of the way, really understanding how users, how they experience, what is their experience? Is it a pleasurable experience? And is it the experience that we wanted to offer them? So here, I'm going to concentrate on the experience that people have interacting with the product itself. And when we create a game, we have a representation, a mental model of what we want the game to be about. So here, when I'm going to say developer, I mean everybody who is participating in developing the game. So not just the programmers, but the designers, the artists, the quality assurance, like everybody. But we have a specific mental model. We know very well what we're trying to do, and we have ideas, but then we need to implement all these ideas in a system. So in games, we use an engine to make the game. When we do that, there's a lot of constraints of the system itself. We can't do all the things that we want. We also have constraints of time, of money, of budget, of people. And so at the end of the day, we don't necessarily have the product. We don't implement the things that we had in mind. And then the users, the players, they coming over, depending, you know, are they coming because their friends are playing, or are they coming because they heard of it, or did they just throw an advertisement on it? So they're going to have a specific expectations of the game. And then they're going to make their own mental model, their own representation of what they believe the game is all about, only through their interaction with the system image. What we call the system image is everything in between the system, so the engine, and people. And so it's everything that players are going to interact with, but also perceive and feel about the game. So when we talk about UX, we have a tendency to focus on UI, on the user interface. Sure, it is part of the experience to interact with the interface, but UX is not just that. It's about the music, it's about the animation, it's about the story, it's about the design. So it's about everything the players are going to experience and feel when they play with the game. So that's really important to understand. It's like really the whole experience players are going to have. And we try to ensure the experience that they're going to have is the one that we wanted for them. And UX is an approach that helps us get there faster and more efficiently. And that's the reason why it's pretty important. So the first thing that we do, we're going to talk about three main elements here. We're going to talk about cognitive science because it's really at the foundation of UX. Because like I said earlier, the experience of a game happens in people's minds. So we need to understand a little bit how the mind works so we can anticipate problems from happening, and we can ensure we're on the right track. Then I'm going to talk about the framework that we use in UX. And lastly, I'm going to talk about the processes and the research that we can do to, you know, all along the way to ensure we are getting there. Because making a game is hard. So cognitive science. This is a diagram of how the brain works, how it learns when we interact with the environment. Please keep in mind that this is extremely simplified. The brain, you know, is much more complex than this, but here we just like overly simplify. When we learn about something, like right now, you're listening to this presentation, hopefully you're gonna learn some interesting things. It always starts with our senses. So we have more than 5 senses. We have a lot of senses. You can sense temperature, for example. But let's say like here for this presentation, the main senses that are making you perceive this presentation is audio. So it's hearing and seeing. And so all these senses, they're going to gather the information from around us and also from inside our body. And we're going to try to perceive this information, and then we're going to process the information that are gathered by our senses. And in the end, if we learn about something, it means that we're going to memorize something new. When we memorize, what's happening is it's changing something physically in our brain. So we have like billions of synapses. A synapse is a connection between neurons. And when we interact with the environment, when we learn what's going on, is these synapses are going to change. So the brain is physically changing as we interact with the environment. A lot of people are saying that, for example, if you play video games, it's going to rewire your brain. This is true. That's because the brain is not pre-wired in the first place. Everything we do in life is going to rewire our brains. So yes, playing a video game, but reading a book, watching a movie, listening to me right now is rewiring your brain. This is normal. This is what we call brain plasticity. And it's actually very important for our brains to be that way so that we can adjust to our ever-changing environment. So between perception and a change in memory, there's a lot of things going on, of course, and there's a lot of factors that are impacting the quality of the learning process. You have biological factors, you have physiological factors. For example, if you had too much to eat, or it can be actually pretty difficult to learn because your body is digesting, or if you didn't have a good night last night, or if you're stressed, all that is going to have an impact on the quality of learning. Here, we're going to mainly talk about attention, and a bit later, we're going to talk a bit about motivation and emotion. But attention is really important. We know that the more we pay attention to something, the better we're going to process that information, and therefore the better we're going to retain it. So attention is really critical to learn. So again, this is a very simplified diagram. The brain is not as simple as that. We don't have independent buckets like these. We don't have a neat serial process as it's shown here, and it's not even a process. We use a lot of terms coming from computers, like process and storing and buffer and stuff like that. But the brain does not work like a computer. The brain is a living organ, and it's extremely complex again. So please keep that in mind. This is just a simplification. So very quickly, I'm going to show you the main limitations of perception, memory, and attention, because we always have that idea that our brain is very powerful and has a lot of abilities, and we're capable of doing some amazing things, which is true. But the brain also has great limitations, and it's really important to understand these limitations so that the product that you're designing, whether it is a game, an app, or whatever, is going to be adjusted to the human brain limitations instead of asking people to adjust to the product. So in UX, the approach that we have is we want to adapt the product to the people, to the humans, and not the other way around. So let's start with perception. One of the main limitations of perception is, well, we're going to talk about that right after. But can you tell me here, what do you perceive in this image? So tell me whatever comes to your mind. You can answer in the chat. Is just to see what are the different answers here. So just tell me what you perceive. Stacks, okay. Contrasting colors, bins, all right. Palettes of colors, bookshelf, menu. So don't I have any gamers in the chat? So I do get a lot of different answers. Characters, okay, but flags, yeah, that comes back fairly often. Okay, so oftentimes when I do my presentation, I have gamers, and these gamers immediately recognize Street Fighter characters. And then I have people that not necessarily are gamers, or are gamers but did not really play that game. And then I get a lot of different answers. So sometimes I get DNA, flags, rugs. What do I get? Lego stacks. So I get a lot of different answers. But this is actually it's a Street Fighter 2 characters minimalized by artist Ashley Browning. The reason why I'm showing you this is to make you understand that perception is subjective. With this same stimulus, we did not all perceive the same thing. Maybe you did see the Street Fighter characters and you did not want to reply. And so if you had a very strong connection with this game, if you played it a lot, or if you know it well, typically people recognize it right away. They recognize the pattern because the brain is a powerful pattern recognizer. But then if you don't really know that game, you can see a lot of different things. And that's because perception is subjective. We're not perceiving the world the way it is. We're not perceiving the reality. We're perceiving a construction of it. So perception is a construction of the brain. We are not perceiving the reality as it is. And here, if you're colorblind, it's about 8% of the male population. You are excluded from my game right now, this little game. And I apologize for that if it's the case. But it's a good reminder for everyone to never use colors only to convey information. And so that's a big limitation. Like, perception is subjective. So what does that mean? It means that when we create something, we are going to create stimuli. So let's take the example of video game, but it's going to be the same thing for anything. If you create an app, you're going to have to create a lot of stimuli. Most of them are going to be visual. Some of them are going to be audio. Maybe you're going to have haptic if you have like buttons, if you create something like physical. But anything you create needs to be perceived appropriately by your users. And because perception is subjective, you're not 100% sure that what is intuitive for you, that makes a lot of sense for you as a designer, as a creator, is going to make sense and going to be perceived in the same way by your users. And so that's the reason why we need to test. We need to test all the things that are really important, and we want to make sure that people perceive them appropriately. So here's an example when I started at Epic Games. So I worked at Epic Games from 2013 to 2017, and I worked on many different projects, but I mainly worked on Fortnite. So when I started on Fortnite, the game was, we already had a prototype for the game. So I brought some players to play the game the way it was. And then I asked them questions about many things, including icons. So it was not just the icons, it's not just the interface, it's just one example. And this was one icon that we had back then in Fortnite. So if you want to try to guess what this icon represented in Fortnite back then, feel free to answer in the chat. But the thing is, so players played for about 20 minutes the game, and so they interacted with the menu and with the icons, and they saw this icon as they were playing. That was the icon that was in the menu. So this was a placeholder menu, that's a prototype. And as you can see, it was representing the category of traps in Fortnite. The problem is when I was asking people, what is this? A lot of them told me, well, it looks like ammunition, or it looks like trees or something related to building. So now we have a problem, because an icon that seemed obvious for us because it looks like, a plank with spikes, now is not completely understood by all players. And so we have a problem with perception. It's not clear for everyone. So this is when we need to iterate on it. And we changed it for an archetype of a trap, so a bear trap, even though there are no bear traps in Fortnite. Once we changed this icon, then everybody understood it immediately. So that's really important to test. Even if for us it seems obvious, we absolutely need to test, because perception is subjective, depending on who you are, what is your prior knowledge, depending on generations, depending on culture, things can be perceived very differently. So this is something it's really important to keep in mind. Perception is subjective. We are not all perceiving the reality in the same way. Another thing, so now we're going to talk about memory. One of the main limitations of memory is that we forget a lot of things. So this is what we call the forgetting curve. That was Hermann Ebbinghaus created that in the 19th century. Back then, he tested himself. So that was one of the first experimental psychology experiments to try to understand a mental process like memory. And so what he created some syllables that did not have any meaning, so that he would not have any familiarity with the material. So he created pages of that. And for example, he took one page and maybe there were, 20 syllables in there, and he learned them by heart. So he went through it and repeated until he knew the whole page by heart. And then he varied the moment he had to recall all these words. So he put the paper down, takes another piece of paper, and writes down all the things he remembers. When it was immediate, he just learned them by heart and tried to recall them. He had 100% good answers. He just learned them by heart. But after only 19 minutes, his retention rate drops down to 60%, which means that he forgot already 40% of the words. And after a day, it drops down to nearly 30%. So that's a worst-case scenario. But when we learn something that doesn't have any meaning, we can lose up to 70% of the content learned from one day to the next. So that's pretty dramatic. And I hope that tomorrow you will remember more than 30% of what we're seeing today for you. But we need to work with that. We need to understand that people are going to forget things. Of course, if the material is meaningful, if it's fun, or if we do exercises on it so that you can really think about it more, it's not going to be as dramatic, but still, people forget things from one day to the next. That's another problem when you create an object, a system, or a game that is supposed to be experienced over several days and sometimes weeks and months. Because from one day to the next, or if players play and then they don't play and they come back a week later, it's very likely that they will have forgotten a bunch of things. So what we do in games to take into account the fact that our memory is fallible, we try to reduce the memory load. So for example, in games, we have the heads-up display, the HUD, and we put a lot of information in there. We try to not put too much because then it's overloading the attention of people. But we try to make sure that players don't have to remember too much. So for example, they always know what weapons they have equipped. They always know what material they have. There's a bunch of information that we always give away to player. And that's the whole point of a HUD. And we need to carefully think about what information players need at all times so that they don't have to remember that information. And so by giving away this information, we're reducing the load on their memory. Another example, in Fortnite, every time you're close to a searchable object, we don't ask players to remember what key they need to press. This information pops up because we don't care. Like, this is not something that we want to challenge players with. So we make sure that this information is always given. Another example in Fortnite is when if you care to craft something, we don't ask you to remember the name of the thing that you want to craft. We don't ask you to remember what are the ingredients that you need for the recipe. You don't need to remember how many of each ingredient you need and which are the ones that you're missing. You can pin that recipe on the HUD, and then you can just focus on, okay, I'm missing copper ore, so I'm just going to do that. So again, like, Fortnite is not a game where we want to challenge players' memory. They are challenged in many other stuff, but this is the sort of things that we do so that we can alleviate the memory load. All right, last thing I'm gonna talk to you about is about, well, you'll see. I'm going to show you some cards, and I would like you to choose one card and try to remember that card as accurately as you can. It's going to go fairly fast. So get ready. Pick a card and remember that card. All right. So I bet I can guess which card you picked and make it disappear. So I hope it worked for you. It's always a bit frustrating for me to do that online because I can't see the reactions of the people. If it did work for you and you're wondering what happened here, I actually changed all the cards. So this is something that magicians do. It's a trick that they know very well. And magicians are actually very versed into the limitations of the brain. This thing, they call that misdirection. So they misdirect your attention. They actually ask you to pay attention to something. And so while you're very busy looking at this, you actually don't see that a lot of things have changed. And this is how they can make the magic trick work. In psychology, this is a phenomenon that's very well known. It's called change blindness. And it's really powerful, is the fact that from one scene to the next, there can be a big change and you might not notice it because our attention is mostly selective. So when we pay attention to something, we're going to really focus on that thing and we're going to filter out the rest. So the rest is going to be in this sort of blackout. And if something is changing in the background, it's very likely that we're not going to notice it. So that's the main problem with attention. Our attention resources are very scarce. We are not good at multitasking. We are not good at paying attention carefully to everything. And the problem, just like the other limitations of the brain, is that we are not aware of it. So not only we have a lot of brain limitations, but on top of that, we are unaware of that. And we believe we memorize things correctly. We believe we perceive things accurately, and we believe we have good attention and we can multitask, and all of that is not true. And so in games, you have a lot of games that are actually challenging attention in players. But what you want to be careful of is to not overload them, especially during the part of the game when they learn a lot of new things. This is what we call the onboarding part of the game. And typically when you learn something new, this is when it requires more attention resources. And so this is when you can't have too many things happening at the same time. And so this is an example of what not to do. This is coming from a playtest session in Fortnite. So very early on, we were testing a lot of situations. How are we going to teach this to player? How are we going to teach them that? So early on, we were testing the sort of things. Like, again, it was very early. Doesn't look particularly beautiful, but we don't care. We're just testing the functionalities. And here we wanted to test how players, how to teach them how to regen their health. So the health is the bar, the green bar on the top left. And the idea is like, okay, we're going to wait until players need to get more health. So we're going to wait until their health bar is going below 50%. And this is when we're going to trigger the tutorial tip for healing. Back then in Fortnite, you needed to consume a health item. So it's the thing that you see with the cross here. So today it's not the case anymore. You need to use a trap to heal, but whatever thing you need to use, you need to understand that you need to regen your health. So it looked like this. So players are combating zombies and they're getting hurt. And so you see on the top left, it's flashing. And at the center, it says gameplay tip, you've been hurt, consume a health item to make yourself feel better, and it disappears. And so what we realized during this playtest is like most players actually did not even perceive that things were flashing in their HUD. And so that's a big thing. Like it's not because you're giving an information on the screen or if you like audio information. It's not because something new is happening that people are necessarily going to pay attention to it. And even if they pay attention to it, they're not necessarily going to really process that information. And even if they process that information, you're not even sure they're going to memorize it and remember it maybe like even 10 minutes later. So we have to take that into account. We're not good at paying attention to many things. We're not good at multitasking. And we have to be aware of that. And if we need players to learn about something, we don't want too many things to happen, because right now the player is focused on destroying the zombies, not on looking and writing stuff on the HUD. So we have to remember that we're not good at multitasking. So very briefly, these are the main limitations of the brain. Perception is subjective, attentional resources are scarce, and memory is fallible. It's really important to understand that, because when you design something for humans, these are the limitations that we have. And so you want to make sure that to offer the best experience possible, you take that into account. Now in games, it's a little bit different because we don't necessarily remove all the frictions as users interact with the game. It's not a tool. So a game will have challenges. You have games that are challenging perception. A game like Monument Valley, it's a game where you change perspective. It's all about challenging perception. You have games that challenge memory, and games, action games and shooters, they challenge attention more specifically. Everything is challenging perception, attention, memory, but you have games that are challenging. It's really more the point of the game. So what we want to do is to remove the frictions that are not by design. Of course, when we do want to challenge players, We're not going to make that simpler, but we're going to make sure that we're going to remove the frictions for the things that we don't want to challenge players on. So this is a quick reminder about the brain. Perception is a construction of the mind. We're not perceiving the reality as it is. So for one reality, there can be many different perceptions of it. Perception is subjective. So we do a lot of tests. We can also use guidelines coming from theories of perception, like Gestalt laws, that help us understand have guidelines so that we know there are elements that we know that humans are going to perceive in certain ways rather than others. And so there are guidelines that exist. But even with that, we still need to test to make sure. Then memory is about encoding information. So really processing that information, then storing that information, and later retrieve that information. The main problem with memory is that the information that we stored, well, we might not be able to retrieve it. We forget a bunch of stuff. And for the things that we do remember, it's actually oftentimes not accurate. We can alter memories. It can also fabricate false memories. So what we try to do is to reduce the memory load for the things that, again, we don't want to challenge players with. We also try to prioritize learning. We try to avoid teaching people too much at the same time, because this is when it's going to be really, really hard to process all that. And so it's not going to be good for retention. So we try to pace it out. So that's the big difference between a video game and a board game. A board game, there's many things we need to learn at the beginning. So you read the instructions and then you play. And this is when it can be hard to understand the game before you actually play one round, because it's just too much to remember at the same time. In video games, we can actually pace it out. We can prioritize what do players need to know now and what we can teach them later. Attention is resources are very scarce. It works like a filter. So we have inattentional blindness or change blindness, and we have low attention span. We can't multitask. So for that, we try to reduce the cognitive load, not showing too much stuff at the same time. And also we use techniques to draw attention. Like if there's something really important that we want players to see or be aware of, we really try to draw attention. So oftentimes we're gonna really do flash, but as a center, or have a big exclamation point and a sound, so that, you know, even if there's a lot of stuff chaotic that's happening, we can still draw their attention. All right, so now that we know a little bit how the brain works, we can have a framework to guide us all throughout the development of the game, so that we can ensure that the game is going to be intuitive to use at the beginning, and understand the rules of the game and, you know, what we need to do, but also it's going to be fun and engaging. So these are the two main pillars of the framework that I use for game UX. So usability, we're going to start with that. It's about the ability of the game to be used. So it's very, this is a notion and the concept that has been a lot, that has been studied a lot. We have decades of research, academic research, and also practitioners research to understand a little bit how to make objects and services and websites or apps more usable, more, you know, for humans to interact with. So we have what we call heuristics. So it's like rule of thumb to ensure that a product is going to be usable. Here, it's an adaptation of the 10 usability heuristics from Jacob Nielsen, and it's an adaptation for video games. Because in video game development, we don't necessarily use the same terms as in the other areas of UX. Like UX has been very, very new in the game industry. And so, for example, when Jacob Nielsen will talk about the visibility of the system status, this is really not terms that we use in the game industry. What we use is signs and feedback. So what does that mean? Is like a sign, it means like if you have a sign from a system, you can understand what you can do with the system. And a feedback is when you interact with the system, when there's an input from the user, is the system giving information back to the user about what they're doing. So if you take the example of an elevator, when you get in the elevator, you have signs that tell you what are different floors that you can go to. If the elevator is done well, you know, it's no brainer. You can, like, if you're going to the 5th floor, you just look at get inside the elevator. They're all a bit different. But if they're done well, you can just like see, okay, number 5, and you understand you need to press on that button to go to the 5th floor. So these are signs. And then when you press on the button, if it's lighting up, this is the feedback that you get from the system, from the elevator, telling you, I got it, I'll take you to the 5th floor. And sometimes you have elevators that don't light up. And so what we do is we typically try to mash up because we're not sure, do I need to do it again, or is it working or not? So we're not entirely sure about what's going on. So when we lack feedback, we're not entirely sure what's going on with the system. So this is signs and feedback. So I'm going to show you an example from games. Then we make sure that they're clear. I'm going to show you examples from form, false function and what that means. Also make sure that these signs and feedback are consistent, because if it's not consistent, then it can be confusing. We minimize the workload. So I gave you already an example for memory. We also make sure that people are not going to make mistakes that we don't want them to do. Of course, in a game, you're going to make mistakes and you're going to die. But there are mistakes that we don't want players to do, or we don't want necessarily for them to be really pixel perfect when they play the game. So we allow some error to happen. And sometimes we also allow recovery from the players. Again, it all depends on where we want to challenge them. And last thing is we try to be flexible with the different options and functionality with the game, and we want to be accessible. So I'm only going to describe a little bit more signs and feedback, form follows function, and flexibility and accessibility, only because we don't have too much time. So I need to pick and choose what to talk about. So signs and feedback in a video game. So for example, if you play that game called Brawl Stars, you have a lot of signs. Like, just look at this. You see what's going on in the game. You see there, something with a red bar. So that's probably an enemy. So you know that you might need to combat this enemy. There are gems over there. So you get this understanding that you can go pick them up. You see different things. You can see, like, for example, here, you see that this thing is going around. So you might understand that once it's going to be complete, you might be able to do something new. So all these are signs. These are signs of what's going on in the system and what you can do with the system. When these signs are clear and they're intuitive, you don't really need a lot of instructions. You can just try to figure it out, because you saw something or there's a big exclamation mark. That's a sign that you can probably do something with a character that's right underneath. So these signs are really important. And for example, so here, once you have the gauge that's going all around, then it means you can actually use a superpower. And here you see that the sign, it's actually even a feedback, when you're trying to start to shoot, the system tells you how far you can shoot, and and it tells you, well, it's going to be pretty narrow. So it means like you have a weapon that can shoot far, but it's not going to be it's going to be quite precise. And here, once your weapon is all charged up, you can see that's actually even farther. And it might be even more powerful because it's a different color. So that's important to really, we spend a lot of time polishing the signs and feedback in the game. So see, it's not just about the UI, it's about the character design, it's about the music, it's about animation. All of that are signs and feedback. And we try to make sure these are as clear as possible so it can guide players without having to give tutorials. And we also try to make sure they are consistent. but that if they try to convey different functionalities, they are different. So here in that game, you can see if you have a different character, when you about to shoot, you're still going to have like, it's consistent because you still have the same visual treatment on it, but it's also telling you different things. Like here, you can see like it's much shorter than with this weapon, and it's broader. So now just by looking at this, you understand that this weapon is probably going to be more powerful at a shorter range, and it's actually less precise. So you don't need to aim as precisely, for example, with this weapon. And this one, you might understand just by looking at it, that it's actually going to throw something, and then this thing's going to explode or whatever is going to happen. And that's going to have an area of effect that corresponds to the circle. All of that has signs and feedback, and they can guide players and help them understand how to play the game without written instruction and without being really right in their face. And that's the part of games that we find fun and try to figure out what this game is all about. But we can only do that if the signs and feedback are very polished. So we spend a lot of time on that. To make them as intuitive as possible, we also try to reach affordance. Affordance it's all about just by looking at an object, can you understand how to use it? So affordance is used, it's a term used in design. And typically, like so I have a mug here, and this handle affords me to grab it like this. So that's an affordance. It's really helping me picking up this object without burning myself. Now in games, we don't really interact with real objects, but we talk about perceived affordance, because just by looking or hearing something, we might understand how we can use it digitally. And in games, we typically use the term form follows function instead of affordance. In architecture also, we use the term form follows function, but it's the same principle. It's just we need to think about the form of an object so that it can tell the users about its functionality. And I talked a lot about interface, but here it's an example from character design in Super Mario. Just by looking at these enemies, you can understand, anticipate how they can be dangerous to you, and maybe how you can defeat them. So the boulder on the top left is attached to the ground. So this one is not going to run after you. It's only going to be dangerous to you if you get close to him. The tortoise, in real life, tortoises are pretty slow. So we can expect that this enemy is not going to go super fast. And because it has a shell, it's probably, you're not going to be able to hurt it that much if you jump on it. Then you have the bullet. You have an expectation that the bullet is going to go very fast in one direction. So you better get out of the way. The flower, when the mouth is open, you see sharp teeth. So it's probably not a good idea to jump on it at that moment. The skeleton is about to throw a bone. So it's probably dangerous to you at a distance. And Bowser, of course, has spikes on his back. So it's probably not a good idea to jump on his back. So this is form follows function applied to character design. And again, the whole point here is to make sure that the things where we don't want to challenge players on are going to be as intuitive as possible without tutorials, without any words. And so that's pretty important for us to reach that, because we are challenging players in many, many things. And here, and Nintendo are very good at prioritizing what they want to challenge players on. They don't want to challenge players into understanding these enemies. They want to challenge them into platforming and reflex and stuff like that. So this is an example of what we're trying to accomplish to make the game as intuitive, as usable as possible. And last thing I wanted to talk to you about is flexibility. So we try to be flexible so that players with different needs or different, they care about different things, they can adjust the game so that, it can fit what they want to do. And that's also very important for accessibility. Accessibility means making the game accessible to people with disabilities. And what it means is that we're going to remove unnecessary barriers to the enjoyment of the game. So we use already one example. I told you that to not use colors only to express things. So typically we will use colors in games, but not alone to convey elements. So we might use color and shape, or color and texture, or color and label, so that if you're colorblind, you can still understand what's going on in the game. And we're not going to add an unnecessary barrier for colorblind players to play, because there's no reason for us to add that barrier. So the idea is try to remove as many barriers as we can so that we can include more people. Here's a great example from the game Into the Dead from Pickpock. It's an iOS game, and so the idea is you can play with your phone or your iPad, and the way it was designed, so it's you have zombies and you need to avoid them. And the idea, what they wanted to do, is to have a tilt control, and so you tilt your device to avoid zombies in landscape mode. The problem is they only wanted to have this control scheme, but this control scheme is not accessible to everyone, because you have people who cannot hold the phone and they need to put it down to play. And so now if you have tilt control only, you can't play if you cannot pick up the phone. And so they decided to create different control schemes to make it more accessible to everyone. And they thought that, most people are going to use the tilt control, and then the rest of the population going to be spread out. Maybe it's going to be 75% tilt control, and then the 25% left will be split across the three others. But then they launched the game and they looked at the data, and it was actually pretty evenly split across 4 options. So here, the point I want to make is when you try to make a game more accessible, what you end up doing is actually making the game having a better UX, offering a better experience to everyone. Because the thing is, we think about disability just in terms of what's the term? It's a bit late for me, so my brain is not entirely functioning right now. Permanent disability. But so let's say you only have one arm, so now you can only play with one arm, so that's a permanent disability. So if you have different control schemes to allow players with one hand to play the game, then it's great, they can play the game. But it's also going to allow people who just broke their arm, so now they have a temporary disability, and they're still going to be able to play the game thanks to that. But you can also be on the bus or holding a baby. And so these are situational, contextual disabilities. And so in that case, you can still play the game because it was made accessible to players with one arm. And so that's the reason why accessibility is so important. First of all, it's the right thing to do to include more people, but it's also going to make the game or the application offering a better experience to everyone. If you're interested in that, I'll suggest you to go to gameaccessibilityguidelines.com. That has a lot of information about accessibility and explains different like basic, intermediate, and advanced implementation that can actually, in the basic one, you can have like a pretty easy to implement functionalities to be more accessible. Okay, so that was usability. That's making sure the game is going to be easy to comprehend, and is going to be easy to use. But a game can be usable and boring. Like, it's not a tool. Like in tools, like again, we want to make sure tools are completely usable. We want to make sure we remove all frustrations and friction points, because the tool is here to help people accomplish a certain goal, an objective that they have. It's not the case for a game. The whole point of interacting with the game is to just be engaged with the game and have fun with the game. And so a game can be usable and boring. So even for tools, we also try to make sure tools are going to be engaging. So it's not, super boring to use the tool. We can also be emotional to use a tool. But for games, it's the whole point. If it's not engaging, We don't play the game, just like we don't watch a movie if it's boring, or we don't read a book if you're like, I don't like that book. So a game has to be engaging. So how do we make a game engaging? That's more complicated because we don't have decades of research for that. So that part, I call that engageability. Other people call that fun. Don Norman calls that emotional design. It's just a bit complicated to really define this. And so in my practice, I ended up using this term, how to make the game more engaging. So the ability of the game to be engaging. So here, this is my framework. To me, there are three main elements to engageability for games. The first one is motivation. You need to be motivated to play the game. If you don't care about the game, then you're not going to play it. So we don't do anything if we're not motivated. Like, you would not be listening to me right now if you were not motivated to listen to me. So it could be you're forced to listen to me, but still a motivation, or you can be interested into this topic. Either way, you need to be motivated to be here. We don't do anything if we're not motivated. So we need to understand how human motivation works so we can make games motivating and engaging. And then emotion is here to support motivation. Of course, if something is emotional and you know, if a movie is funny, for example, that creates emotions, or sad, we also like sad movies, that's going to make it more engaging. And in games, we also talk about the notion of game flow. We want to make sure like players can really be in the flow, when they can be super concentrated into what they're doing. They lose track of time. And so to do that, we try to make sure that the game is not too easy because it's boring, but also not too hard because it's stressful. So we try to make sure that it's always in that sweet spot when it's not too easy, not too hard. But let's talk about, I'm mostly going to talk about motivation here. You have, so it's a bit complicated. We don't understand well how human motivation works. There's a lot of theories out there. But let's say there are two main motivations that we're looking into. The first one is extrinsic motivation. Extrinsic motivation is the motivation of doing something, but in order to gain something else that is external to the task. So for example, in a game, you might want to complete a mission, not because you care about this mission, but because you want a specific reward, because with this reward, you're going to be able to accomplish your goal. So there are things that we do in life. Maybe you're doing a job that you don't care about, but you need the money to pay for things that you do care about. So that's extrinsic motivation. And we know that we humans are, and animals, we're motivated to do many things because of the rewards. So for this to be able to work, you need to make sure you have clear goals and clear rewards associated with these goals. These goals need to not just be immediate or super far away in the future. It's important to have short-term, medium-term, and long-term goals and clear rewards associated to these goals. So in a game like Pokemon, you have this that's very clear. Like, you have short-term goals that are very clear, you have the medium-term goals that are clear, and long-term goals that are clear. So sometimes in games, it's in the design, but it's not clearly conveyed to players. So that's going to be important in games when you just make sure that players, have goals and they can understand what they're going to get from accomplishing these goals. But this is interesting and it's important, but it's not just that is important. We also care about intrinsic motivation. That's the motivation of doing something for the pleasure of doing it, not for gaining something external. So the best theory that we have out there for intrinsic motivation is called self-determination theory, or SDT for short. It explains that humans are more motivated to do certain activities when these activities satisfy our needs for competence, autonomy, and relatedness. Competence is mainly about a sense of progression. Sorry, I think someone is unmuted. So if you could mute, because there's a bunch of noise. Thank you. So it's the sense of progression. So if you do an activity, let's say you learn how to play the guitar, and if you practice every day, you will see that you get better at it. You feel that you're progressing, and that feels good. When we try to do an activity and we don't feel that we're progressing, this is typically very demotivating. It's really hard to keep going if we don't see ourselves progressing. So this progress can be skill-based, like playing the guitar, or sometimes in some games, it can be more artificial. So in RPGs, role-playing games, you level up. And when you level up, you're going to earn points. And with these points, you can buy an ability that is artificially going to make you more powerful within the system of the game. So if it's skill-based or not, what's important here is to have a sense of progression. And that's the reason why progression bars are typically very powerful. It's not just because you know that once the bar is filled, you're going to have a reward. It's actually because it's giving you a very good feedback on your progression. You can see yourself progressing to this goal. So that's a sense of progression. We also care about our autonomy. We need to express ourselves. We need to be able to make meaningful choices. This is actually pretty important in life. So all the things I'm telling you here is not just for games, it's in life as well. We need to be able to, we like to have an objective, but then we choose how we're going to get there. So in games, you have games that are sandbox games where you can really choose to do what you want to do, or games where you have different ways to accomplish your goal. So that gives you more autonomy. But it can also be by choosing your skin or your dance moves, being able to express yourself, being creative. And last but not least is relatedness. We're a very social species. We need each other to survive. And so we need a way to communicate. And in games, it's oftentimes the cooperation. So you can play together to cooperate, or it could be competition. There's a lot of focus on competition, but actually cooperation is even more powerful. And a lot of games or sports are oftentimes team-based. So yes, you're going to compete against another team, but oftentimes you cooperate within your team. So it's really important to think about that when we make games or when we try to gamify something to make sure your user or your players are going to feel a sense of competence, autonomy, and relatedness. So if you look at a game, it's an old screenshot from Overwatch. They express that in the lobby. Like here, you can choose your role. So you have autonomy. You can also choose your skin. So that's autonomy. You are part of the team. That's relatedness. And you can see your level here. So that's competence. And you can even see here how to make your team more competent. So they give you a feedback like, hey, you don't have any healers. Maybe that would be a good thing to have healers on your team. And so that's giving you some indication about how to be more competent as a team. So these are the kind of things we're trying to express in games and make sure that players feel competent, autonomous, and some relatedness. I'm briefly going to talk about emotion because I talk too much. So I don't have too much time left and I want to have enough time for your questions. Video games are in an art form. So just like movies or music, of course, we want people to feel certain emotions. In games, the main way to do that is called game feel. So it's how are you going to feel as you interact with the system? So how good does it feel to play with a game? So we look at what we call the 3 C's. 3 C's stands for camera, characters, and controls. So how does the controls feel? Do you need to press like 10 things to do something, or can you easily do something to feel more powerful? It's about the camera. If you have a first-person camera, it's not going to feel the same that if you have a top-down camera. So top-down camera is good for tactical, strategic games so that you have an overview of what's going on. First-person camera is going to be more important if you want action and to feel more stress and stuff like that. Sense of presence is, do I feel present in the environment? Do I feel that I'm part of this world? Like, for example, if you could just click on the button to build a building in the game to get wood or whatever. And it could be just an icon, say, build a meal, and then you just see a box and then it says meal. So you have the functionality here, but then you don't really feel a sense of presence. You don't really feel that you're part of the world that's living. In a game like Clash of Clans, you decide to build a meal, and then you see some scaffolding, and you see immediately some characters that are coming over and, you know, building the thing, and you have sound effects, and so it feels real and feels that you are a part of the world, and you also have like physical reality, because it feels as if it was physically real. So that's game feel. It's really important to, you know, like to have that sense that it feels good when you interact with the game. And we also need to bring some novelty. So typically when, you know, at some point everything is routine and nothing is new, it can become boring. It's a novelty. We use that to raise awareness and make sure, you know, that people are not getting bored. So having some discovery and surprises, like for example in Zelda, you see cracks in the wall that's stimulating your curiosity, or in Fortnite or in Diablo, you have a chest and you try to open it, but hey, surprise, this is actually a mimic, so it's actually an enemy. On Uncharted, you are in a ship that is sinking. As it's sinking, it's tilting 90 degrees, or rotating 90 degrees. And this is also tilting all your controls 90 degrees. So if you push forward, you're actually going to turn right. And this is going to bring something new, and like, oh no. And so that's raising your awareness. So that's one of the things that we do also in games, so that it's not always the same. So we bring some surprises here. So game flow is mainly about the level of challenge, like I said, not too easy, not too hard. But it's also about the rhythm of stress and pressure. We don't want the players to always have to, you know, there's a lot of enemies all the time, because then at some point getting out, it's getting too intense. So we have moments like, for example, we have waves of enemies, but then, you know, moments when you can look at your inventory and plan your next move. So it's not always like super intense. And we also think about the onboarding and the learning curve, how players, they're going to learn the game, what is going to be complicated to learn, you know, how we can bring them there without trying to teach them too much at the same time, etc. So it's really important for us to think about that. And to do that, we try also to make things meaningful for players. For example, in Fortnite, so I mainly worked on the Save the World mode of the game. We teach players how to build the first time when they're in a cave, and then they're at the bottom of the cave, but then they can't get out. And this is when we teach them to build stairs. And so at the moment we teach them to build stairs, it's meaningful to them because they need to learn that to get out. So that's what we call learning by doing in a meaningful way. That's going to be really important for things that are really critical in a game or in an app or whatever it is, to make sure you teach them something, your users, at the moment they really need it, and it's meaningful for them to do that. So that's really, really important. Like, we care about the why. Why would your users care about this at this moment? So that's it. That's the framework that we use. Like, think of it as a checklist. Because our memory is fallible, we rely on a checklist. Just like pilots, even though they're super highly trained, they still rely on a checklist because they know that memory is fallible. So same thing for us. We're under stress when we create something. And so we need to make sure we have a checklist so that we don't forget anything. And when we have a problem, we try to understand where it's coming from. So it's actually much faster to fix it. And to do that, we need to have a really strong process, and we need to have a scientific approach. So humans have problems. We have biases. As a creator, you have what we call the curse of knowledge. You know your creation or what you're trying to accomplish too well. And the problem is that it's hard to put ourselves in the shoes of someone who doesn't know anything about your game or your app or whatever it is. And so it's really hard for us to anticipate, to try to forget about what we know, to be able to anticipate how people who don't know anything about this are gonna, what mental model they're gonna have of it. And on top of that, so our memory is fallible. We have not the same perception, and it can be hard to pay attention to too many things at the same time. We also have a lot of cognitive biases that are coming from these main limitations. So I'm not going to tell you cover all of them. We have way too many, but it's important to understand that we are biased. And so because we are biased, what we try to do is to have a scientific approach. Science is the importance of science is all about the methodology, so that we can try to gain knowledge by applying a very strict methodology to understand the world around us. Without science, we can just, like, if we rely just on our gut feeling, then we can have confirmation bias, and there's a lot of things that are going to happen, and it's going to be really hard to understand the truth. So we have very strict protocols and standardization of experiments so that we can try to understand the truth. Of course, in video games, we're not as rigorous as in academic science, but we do try to apply as rigorous as possible of a methodology so that we are not going to fall for our confirmation bias, and that we can make sure that the results that we get are as accurate as possible, and not, just relying on our gut feelings that can be very deceiving. So we do that. We bring players over, we watch what they're doing, and when something happens that we did not intend, like, for example, players are frustrated about something, or they don't understand something, or they're not using an ability, we try to understand why this is happening so that we can fix it. So in Fortnite, for example, we did a lot of tests very early on, and we had players in online tests. And so online, they were testing the game, and then we were sending surveys to see, what they liked, didn't like, understood, not understood. And at some point, like, players were complaining that the game was too grindy. It took too much time for them to gather material. And at some point, so it was not too bad, the first levels, because you can craft things very fast. But at some point, let's say when you're level 10, you actually need to gather a lot of resources if you want to craft a weapon that's good for your level. And so at some point, they really found that it was taking way too much for them to gather material to craft the things they cared about. So when this happened, oftentimes people want to fix the design. Like, well, that's not working. Like, it's not balanced. You need to fix the design, check your design, what's going on with your design. So yes, you can of course check the design. Maybe so this is what we call system design. It's just math. It's like spreadsheets, and yeah, maybe there's an error in there, and then maybe at some point, because of that error, it really it's really taking too long for people to gather resources. But the system designer came back to me saying, no, my math is sound. It's not coming from there. Okay, so this is, if it's not coming from the reality of the design, then you need to understand why people have this perception of it. Again, perception is subjective. So even if on paper looks good, maybe there's something that is making them perceive it differently. So this is when we start to investigate. Why are they perceiving harvesting, too long at some point? And the thing is, in Fortnite, you have this. It's called the weak point. And in Fortnite, this is appearing when you start destroying something in the environment to gather this resource. What it's supposed to say, it's supposed to tell players where to aim so that they're going to hit a weak point on this object. And so if they hit that weak point, it's going to destroy that object much faster. And so they're going to harvest things much faster. The whole system design was based on the assumption that players are going to use this weak point. The problem is that in playtests, we were seeing this. Players were not using it. And when afterwards I was asking them through surveys, just like this, I was showing this screenshot with an arrow. I said, what is this? And at that point, they were telling me, no idea. Okay, so to me, it was inattentional blindness. If they don't see the weak point, they're not going to use it. And if they don't use it, then of course, at some point, it's going to take really a long time for them to gather resources. Okay, so let's iterate on it. Let's make it bigger, have a color that really contrasts with the background. It was pulsing inward. It looks like a target. All right, let's test this. that didn't work. And so that was surprising. And we asked players, so what is this? And at that point, they were telling us something like, oh, this is the element telling me that I'm targeting this object. Okay, so now they see it, but it's still not good at conveying the functionality of this. So we need to still work on it. And the thing is, the designers had a great idea. They thought, you know what, let's remove it from the beginning of the game so there's no weak point. And then we're going to add this ability as a skill in the skill tree. And so players, as they level up, they can unlock this in the skill tree. And we're going to put a lot of text explaining what it does. But of course, most players don't read. That's the thing. We always think that we're going to add more text and that's going to solve everything. But most people do not read. And so, but, you know, there's more things happening. You know, you go into the menu, you have a new quest about it. So get into the menu, you see the pickaxe, and then you see a video of it. So there's a lot of stuff happening around it. And also now it's a reward that is meaningful because you didn't have it, now you have it. So there's more chances that you're going to pay attention to it because it's new. And so after we did that, finally, players were hitting it. So that's an example of how we try to fix problems. We're not just reacting to what people say. It's important to take into account what they say, but then we go on an investigation to try to understand why this is happening. So that's the reason why we don't follow necessarily what players are saying, telling us, like fix this, fix that. We are the ones, you know, understanding this system, and we need to try to understand why this is happening. And very oftentimes, it's not coming from the design. The reality of the design is coming from a perception of it. So we need to fix that perception. So it's really important to have a pipeline, to know what we're looking for, to have hypotheses. When we do UX research, like all these play tests that you saw, because we're not just testing the game and say, well, let's test it and see what happens. No, we have hypotheses, like for the weak point. We have a problem, so we try to understand where this is coming from. And so we start a test with, not just one hypothesis, but we start a test with very precise questions we're here to answer. So it's really important to have research as part of the whole process and not an afterthought, because there's always something that we can test early on, even though we can test everything at the beginning, but there's always something that we can test. So it's really important to think about this very early and to really have that mindset of we're going to iterate little by little, and very often have humans testing our products so we can see if we're on the right track, and if not, how we can fix it. And this is what UX is about. It's a mindset. UX is the concern of everyone. If you're working on a game, on a system, on a service, on a website, or whatever it is, you should care about what experience people who are going to use that object or service are going to have. Who are these people? What are they trying to do? And what is going to be their experience? And of course, if it's a game, are they going to have fun? If not, how we can fix that? And so UX is not just a responsibility with people with UX in their titles, it's the responsibility of everyone on the team. Now, the people who have UX in their title, they bring some knowledge like cognitive science, or what we call HCI, human-computer interaction, or a certain methodology to get everyone to get there. But we are all responsible for the experience that we offer to people in the end. And so now that I've said that, we can look at the different UX roles. And if you're, so UX is becoming very trendy. It's very important today. Like, people understand now a bit better what UX is about. They don't necessarily understand precisely what it is about, but they understand better that, okay, we need it. And so there's a lot of UX roles that are that people are looking for to hire. So for example, there's a lot of requests for UX designers. UX designers, they're not here for just the visual design or just for UI. And that's the problem. Like, you will often see UX/UI. And that's because people don't necessarily understand what UX designers do. UX designers, they're actually, initially they were called interaction designers, which was a better term for that. But what they do is they care about the interaction design. That, for example, let's say you have a game and you're gonna have crafting in the game. Okay, how do players gonna do that? You know, what is the information that we give them and where? And what is the information architecture? Would they see, for example, a menu with the different recipes, and when they click on it, they would see maybe their inventory and see, you know, what do they have? How do they craft? What do they click on the button, or do they drag and drop the ingredients that they have in their inventory to drag it? And, you know, I don't know, an area where you just craft. How does that work? So all of that is thinking about the interaction design, how people are going to interact with the system, and what information we give them where. And sometimes there's some consideration about visual design. So UX designers are here to make things functional for players. So game designers, a system designer, they define the rules of the game, they define all the specs, and then UX designers are here to ensure that players understand them and they can interact properly with the system to accomplish their goals. Then you have UX researchers. They're here to measure the best way they can what experience in the end or during the process, you know, what experience players or users have effectively, and is this matching the intention that we had initially? If yes, awesome, we're on the good track. If not, okay, why is this happening and how we can fix it? You also have UX data analysts. So these are people doing data science, and there's the important part is analysts. So they gather data just like UX researchers, but the data they gather is from telemetry data. So it's from a distance. We gather a lot of data, and there's also like people like to be data driven, and they don't necessarily know what that means. You actually don't want to be driven by data. You want to get insights from the data, and to get insights from the data, you need to understand why you're gathering this data. What are you going to do once you have the information? And that's what UX data analysts do. So it's a bit like UX researchers. They try to measure what experience people have and how we can fix it, but they don't use the same data. It's quantitative data, whereas UX researchers typically deal more with qualitative data, and both need to work together. So data analysts, they get the data later on. Typically, UX researchers have data earlier because they bring people over to test a prototype. But at that moment, we don't have telemetry data yet. But once we do, it's important for UX researchers and data analysts to work together. And then you have UX strategists. So this is more what I do. So I was director of UX at Epic Games. The main things we do is we advocate for UX. We explain what this is about, why do we need it, and then we try to, so we manage the teams, we coordinate, we ensure everyone is aligned, we ensure that everybody understands what experience we want to offer and who is our users, so we can ensure we understand what they're trying to accomplish. We make sure that we have the right people. We have UX designers, for example, and researchers, that we have the right resources, that we have the right processes, et cetera, et cetera. So this gives you a little bit of an idea of what are the UX roles. These roles are pretty common. It's not just in games. You will find them. So sometimes we don't call them UX researchers. So it's going to be more user researchers and data analysts. Sometimes you don't have the UX because you have data analysts for business goals and you have data analysts for UX goals. So our goal when we do UX is to ensure players are going to have the best experience possible. And we think about the user's best interest in mind. Sometimes when you're too business focused, we try to just make the most money as we can. But this is not what UX professionals are about. Sure, we care about the business goals, but we're here to defend the user. We're here to fight for the human and fight for the users. Keep in mind that most companies don't have a very good maturity in UX. So that's the reason why people don't necessarily understand what UX designers do, or they don't understand what UX is about. And so A lot of companies are still around 2 or 3. It's very rare to have a company that is at level 5, where everything you have a really UX culture. Like Apple is one of the companies that is more advanced because they really think about the experience users going to have from the first time they hear about a product to all the way to customer experience. They really have that mentality, that culture to think about the experience of users. But it's pretty rare today to have a company that's super advanced in terms of UX. So yes, UX is trendy, but keep in mind that there's still a lot of maturity to get there. And the last thing I wanted to tell you, so I already hinted to that a bit earlier. When we have a UX mindset, we put the human first. And so UX approach is incompatible with the use of dark patterns of shady practices. So sometimes you're going to have people saying they do UX and what they're trying to do is to optimize your business. Well, this is not what we do. What we want to do is optimize the experience for users. And we think about the best interest first. So we're not going to try to trick them to buy something without them really wanting it, or trick them into staying on the platform or coming back when they don't really want to come back, but we make them come back because if they are not back, then going to miss out on something amazing. So all these are what we call dark patterns or shady practices. We see that all over the place. I mean, it's not new, but it's important to point them out. And when you have a UX mindset, again, you think about the human first. So I started an initiative with several colleagues in the game industry. It's called ethicalgames.org to try to raise the bar of ethics in the game industry for players, of course, but also for the workers in the game industry also. Because we have practices like, for example, we're not super inclusive in the game industry. There's still not a lot of people of color and not a lot of women. And so we're trying to also make that better. There's also a lot of overtime practices that's really intense in the game industry. We have a nice term for it. We call that crunch. And because today in the game industry, we need to, it's not like we ship a game and then we're good. We ship the game and then the real work starts because it's game as a service. And so now it never stops. So there's a lot of teams are crunching for long periods of time, and it's getting really difficult for people. And also raising the bar for accessibility and inclusion overall for our games. So if you're interested, you can take a look at the website. So yeah, that's pretty much it. So keep in mind that the brain is very good at making sense of our environment with very little information. We take shortcuts all the time. Your users, when you create a product, they're going to take shortcuts. Most of the time it works, but every now and then it's actually misleading us and we draw the wrong conclusions. We do that, our users are going to do that. So it's really important to understand what UX is about so that we can ensure we're on the right track and we can make sure that we build a product or service, a system that is going to be adapted for the humans and not ask the humans to adjust to our product. So that's it for me. Of course, I will answer your questions. So thank you so much for your attention. I have a lot of resources on my blog. So it's celiahodent.com. There's a lot of posts in there. You're going to have like a post called the UX of Fortnite. It's really talking through all the things that we saw today. It's also, of course, in my book, The Gamer's Brain, like are we going deep down in all these concepts. There's a lot of stuff in there. On my blog, also, you will find a post. So that's the most recent post that I made. So you'll easily find it. That explains how to get a job in the game industry and with a focus on UX roles. So you have a lot of tips there to how to get a job in the game industry. Of course, it's more Western focus because I'm French and I live in the US. So maybe not everything is applicable for everywhere, but you still have a lot of tips that should be applicable for everyone. What else? The other book, The Psychology of Video Games, this is not a professional book. So The Gamer's Brain is a professional book. The Psychology of Video Games it's a very short book, and this is for a very broad audience. It's to explain how psychology is used to make games, so UX, but it also explains what the impact of playing video games on players. So it's really like for a broad audience, super short. What else can I tell you? I'm pretty active on Twitter, on LinkedIn. So if you don't have a chance to answer, to ask your question here, you can also try to contact me on Twitter or LinkedIn. And yeah, that's pretty much it. So thank you so much for your attention, and I will answer your questions if you have any.